There is a programmer right now somewhere with no degree, no boot camp certificate, no formal training of any kind, who just got hired at a company that rejected a dozen computer science graduates. This happens more than the academic world would like to admit. And it is not because self-taught programmers are smarter. It is not because CS degrees are worthless. It is because somewhere along the way, the self-taught programmer did one specific thing that most CS students are never forced to do. And that one thing changes everything about how fast you learn, how deeply you understand, and how quickly you become someone that companies actually want to hire. This is not a story about shortcuts. It is a story about the difference between studying programming and actually thinking like a programmer. Let us start with how most people learn to code. You open a course, maybe it is on YouTube, maybe it is Udemy or Coursera or a university syllabus. You watch someone explain variables. You watch someone explain loops. You watch someone explain functions. You follow along, you type what they type, the code runs, and you feel good. You feel like you are learning. You move to the next lesson. You keep watching, you keep typing, you finish the course. And then someone asks you to build something from scratch. Anything. A simple to-do list, a basic calculator, a program that reads a file and counts words, and you freeze. This experience is so common in programming education that it has a name. Developers call it tutorial hell. You can watch 100 hours of programming tutorials and still not be able to write 20 lines of original code on your own. Researcher Neil Brown, in a 2018 study published in the ACM Transactions on Computing Education, found that a majority of beginner programmers who complete structured courses cannot transfer their knowledge to new problems without heavy scaffolding. They can follow. They cannot yet think. This is not a personal failure. It is a structural one. Here is where the self-taught programmer diverges. At some point, out of impatience or necessity, the self-taught programmer stops watching and starts building something they actually want to exist. Not a tutorial project. Something real, something broken, something that does not work yet and needs to work. Maybe it is a script that renames files automatically. Maybe it is a small game. It does not matter what it is. What matters is that it is theirs, and it does not work yet, and they have to figure out why. This is called project-driven learning, and the research behind it is overwhelming. Psychologist Seymour Papert at MIT spent decades studying how people learn complex skills. His theory, which he called constructionism, argued that people learn best not by receiving information, but by building things. Not by being told how something works, but by trying to make something work, failing, and trying again. Neuroscientist Robert Bjork at UCLA has spent decades researching what he calls desirable difficulties. When something is effortful, when you have to struggle to retrieve information, your brain builds stronger, more flexible neural pathways. You remember and understand things far better when you generate the answer yourself than when you are shown it directly. A tutorial removes all desirable difficulty. It shows you the answer before you have struggled for it. Your brain files it away shallowly. You recognize it when you see it again, but you cannot produce it on your own. A personal project does the opposite. You hit a wall. You do not know how to do what you need to do. You have to search and fail and search again. That struggle is not a sign you are bad at this. That struggle is the learning. When you build your own project and something breaks, you do not just fix the bug. You learn something about how the language behaves. You learn where your mental model was wrong and you correct it. Every bug you fix deposits a piece of real understanding into your mind that no tutorial could have given you, because the tutorial would have prevented the bug from happening in the first place. Self-taught programmers also develop something the academic framing of programming almost never emphasizes: how to read documentation. Real programming is not about memorizing syntax. Syntax changes. Languages evolve. The skill that compounds over an entire career is not knowing things. It is knowing how to find things. Reading a technical specification or an API guide is a trained skill. Self-taught programmers develop it because they have to. The tutorial ran out. The answer is in the docs, and there is nowhere else to go. None of this means you should skip formal education. A CS degree gives you algorithms, data structures, and the mathematical foundations of why computers work. These things matter, but the ability that makes someone actually hireable is built by doing. Only by doing. So if you are learning to code right now, here is the only advice that research, experience, and hiring data all agree on. Stop watching. Start building something you care about, even if you have no idea how to finish it. Let it be broken. Let it confuse you. Sit in the discomfort of not knowing and push through it anyway. The programmer who pushed through that discomfort 500 times is not smarter than you. They just have 500 moments of real understanding that no tutorial ever gave them. And right now, you are one project away from the first one. The person who pressed play on a tutorial today and the person who gets hired next year are not that different yet. The difference will be made by what they do when the tutorial ends.